Hi, this is your Professor Sudha Kolathuparambil. I am going to explain you the concavity and the point of inflection. I hope you all like pasta. This is made out of elbow macaroni, right? So you are familiar with the macaroni. So you might be wondering, why am I using the macaroni to teach the concavity and point of inflection? We are in a math class, right? Let's look at the shape of this pasta. Let's pick up four elbow macaroni from this pile. I'm going to place these four pieces of macaroni here. So I picked four pieces from here and I'm placing it here. You can think these as four functions. So if I move along the graph, you can see that the graph is increasing. That means it is keep on rising from left to right. But if I move from left to right along this graph, this is dropping from left to right. That means the graph is said to be decreasing. How about in this one? I'm moving along the graph from left to right, so you can see that it is still dropping or decreasing. But in this graph I'm going upward, you can see that. So this is increasing graph. So these two graphs are increasing, these two graphs are decreasing. If you draw a tangent line anywhere in this graph, the slope will be positive. Same thing here, since this is increasing graph, slope will be positive. But for a decreasing graph, the slope will be negative slope. So this will be negative slope. This piece also will have the slope of the tangent line negative. If the graph is increasing, the slope of the tangent line will be positive. If the graph is decreasing, the slope of the tangent line will be negative. Let's pick four pieces of macaroni from there and make a shape like that. So this is one piece. I'm putting another one next to that. So I got a shape like that. I can make another shape like putting two pieces together. So I got another shapes like that. Assume that these two are two functions. This is f and this is g. If you draw any tangent line here, you can see the slope of the tangent line is increasing here. That means f prime is increasing for this graph. If f prime is increasing in this interval, we can say that the original function f is concave up. For this graph, if you draw a tangent line, you can see that slope of the tangent line is decreasing. So we can say that f prime is decreasing in that interval I. So original function f is concave down. If you have a shape like U, that is concave up. If it is an upside down U, that is concave down. So if it is concave up, f double prime will be positive, and if it is concave down, f double prime will be a negative. That means f prime is decreasing, f prime decreasing in this one, and here f prime is increasing. And the original function f is concave up here, and in this case original function f will be concave down. So I'm using like a CU and CD to represent like a concave up and concave down. Again, let's go back to that four pieces of macaroni. 1, 2, 3, 4, like that, right? We can actually put these four pieces together to make different shapes like that, or like this, or it could be like that, right? If I joined this piece and this one together, okay, so what is the other shape? Maybe these two, if I join, what should I get? Like this. Okay, so for any graph we can think of like it's all formed by like joining these four pieces of macaroni. That will be easier to think. Okay, so there are four cases, like here you can see that f prime is, it is an increasing graph, so positive. This is also increasing, so f prime positive. Here f prime negative, here f prime negative, because slope is negative. Slope of the tangent line is negative. And here these two pieces are concave down like this, right? And this is concave up. So here f double prime is positive. Here also f double prime is positive. But in this case, this is concave down, so f double prime will be negative. Our approach in this section is, we will find the interval where the graph is increasing or decreasing, or interval where the graph is concave up or concave down. Then we need to identify the shape of the graph and sketch that graph. So if you end up with f prime is negative and f double prime positive, we know that this will be the shape of the graph. Then we can, this will be the shape of the graph in that interval. And in the next interval, look at the what are our findings. So if we find that f prime is negative and f double prime is also negative in that interval, so the next piece, the graph will be, the shape of the graph will be like this. If you look at this graph, you can see that this is concave down, then it is concave up. So at this point, the concavity is changing. That point is known as the point of inflection. This graph also, this is concave up to here, then it is changing to concave down. So this point is known as the point of inflection. So point of inflection is where the concavity changing. If this is the shape of the graph, this is the point of inflection. In short form, I am writing PI. So here, this is the point of inflection. Point of inflection is a point on the graph. It should be on the graph. Okay, so at the point of inflection, the second derivative at that point, assume this is at x equals 0. So second derivative at that point will be equal 0, or f double prime at that point does not exist. So let's look at the point of inflection again. Like if the concavity of the function or f double prime is changing from, here it is concave up, right? So it is changing from positive to negative at this point. That point is known as the point of inflection. Here it is concave down, then at this point the concavity is changing to concave up. That means f double prime is changing from negative to positive. So this point is known as the point of inflection. And in this graph, this is concave down, then this is the point of inflection. Concavity is changing here, but here if you draw a tangent line where the slope is not 0, slope will be slope of the tangent line, that means f double prime at that point will be undefined. It does not exist. So f double prime at this point, assume that is at x0, here it does not exist. In these two cases, it will be 0. Let's analyze the three graphs f prime and f double prime to understand these concept in depth. In this one, we have f. This is the derivative of that function. So while looking at the graph, we know that this is a cubic function. If I take the derivative, it will be a square function, right, or quadratic function. So that is this one. If I compare these two, I know that the original function has a relative minimum and relative maximum here. That means if I take a tangent lines, the slope of the tangent line will be 0, right? At this point, slope will be 0. That's the same thing you can see that in f prime graph. This is the slope graph or slope function f prime. You can see that f prime is 0 at these 2 points, right? Okay, at these 2 points, f prime is 0. This is f prime graph. So f prime is 0. So now let's look at the relation between these 2 points. This occurs at the same value of x. So when x equal, assume this is at x0 or something, and this is, or x1, let's say x1, this is x2. So when x equal x1, the slope of the tangent line at the original function is 0. That corresponds to the x-intercept of the f prime graph. Same thing, there is a maximum at the original function. That means this tangent line or the slope of the tangent line at that point is 0. That corresponds to the x-intercept of the f prime graph. If you look at the f prime graph, this piece is above the x-axis and this piece of the graph is also above the x-axis. This is below the x-axis. So if whatever the part of the graph is above the x-axis, there f prime is positive. If it is below the x-axis, f prime will be negative. So if it is above the x-axis, so that is positive, this is positive, this is negative, right? If f prime is positive, that means that original graph is increasing in that interval, and if it is negative in that interval, the original graph will be decreasing in that interval. So decreasing in that interval, this here f is increasing. So let's look at that again. Original function f is increasing, that means f prime is positive. If f prime is positive in this interval, that means the original function f is increasing in that interval. If f prime is negative in that interval, the original function will be decreasing in that interval. By looking at this graph, can you identify f prime and f double prime? This is f, this is f prime, this is f double prime. Because if the f graph is, assume that is x cube or something, if I take the derivative, that is 3x square. If I take the derivative again, that is 6x. So this is a line, this is a u-shaped graph, this is a cubic graph, right? So that's how I identify that. Another thing, let's look at the relation between these graphs. So in the previous graph, we learned that if this is the relative minimum, it corresponds to the x-intercept of f prime. That means slope is 0 here. So here f prime is 0. Same thing if it has a maximum here, relative maximum at this point, it corresponds to the x-intercept of f prime graph. Now let's look at the concavity. If you look at the original function, it concave down up to here, then it is concave up. So concave down, then concave up. So concavity is changing somewhere here. So that concavity is changing somewhere here means that correspond to the x-intercept of f double prime graph. So this is the point of inflection. So the point of inflection is the point, this is the x coordinate, y coordinate will be -2, right? So we can write point of inflection as -0.444, -2, and concave down in the interval -∞ to -0.44, and concave up from -0.44 to +∞. And the point of inflection is where the concavity of the graph changing. And remember that these are the interval in the x-axis, okay, -∞ to infinity. These are the x values, okay. Because I was showing the shape of the graph by moving along the graph. So don't think that I'm talking about the y values or anything. These are the interval, means we are talking about the x values. So from -∞ to here. So -∞ to -0.44, this graph is concave down, and in in this interval negative 0.44 to positive infinity, the graph is concave upward.